All right, we're going to finish section 6.4 today. We have just a couple more examples, examples 7 and 8, and we're looking in this section at some proportion ideas. So we've got Mary in example 7, and she's working with measurements, and she writes the following proportion. 12 inches over 1 foot equals 5 feet over 60 inches. How would you help her? So this is sort of a personal preference thing, but I think that it's a good idea when you're working with a student to affirm what they've done correctly. Even if the problem ends up being wrong in the end, it helps them to know what they set up that was right. So can you look at this and identify something that she set up that was right?
12 inches to 1 foot.
Yeah. So the proportion on the the ratio, excuse me, on the left-hand side is correct. 12 inches is comparable to 1 foot, right? How about the one on the right?
Aren't there 60 inches and 5 feet? Like, should be the multiplication of
Yeah. So each of the individual ratios are correct. So her individual ratios Okay, so the individual ratios are correct, so that's good. Way to go, Mary. She's got, her 1 foot to 12 inches. She's multiplied the 5 feet by the 12 correctly to get the 5 feet to 60 inches. So let's talk about anything that maybe is going wrong now. So what's going wrong with the way that this is set up?
She needs to flip the 5, make 60 inches on top and 5 feet on bottom.
Okay, so you would like for this to say 60 inches over 5 feet instead. So I agree. Why do we want it flipped?
Something about the measurements being in line with each other.
Yeah. So the comparisons need to match. So if you'll remember when we were setting things up last time, I was kind of a little bit OCD about labeling things, right? Teachers, students. We've got the ratio and the actual number. Over here, I did Kierra and I did Dora, and then we had the time and the pay. And so this idea of lining things up so that they're in the correct location comparably is really important. So when we set this up over here for Mary, her correspondences need to match, right? So if she's comparing inches, they both need to be inches on top. The feet would both be on bottom, right? Or if she wanted to do it so that the inches top and bottom on one side matched the inches top and bottom on the other side, something like that, that'll be okay too. But if this is the simplest thing to fix, is to either fix the 60 and the 5 or to change the 12 and the 1, that would be okay as well. Not both, can't do both, you've got to use just one of them. But we need them to sort of line up correctly, like Elizabeth said. So she needs the units, I'm going to say it that way, in the ratios to compare in the same way. If the left side is inches over feet, the right side should be 2. Right? It's lining things up in the same way. Huh. Any questions on that? All right. A fun one to end with.
Is that all you, like, it's just how would you help her? You don't need to. Okay.
Yeah. So you're going to write language down like you were really talking to her. Okay. So, or at least identify what you would kind of explain to her in the language you're reporting back to me. So I like questions like this, not necessarily this exactly, but where you're explaining something to a student, identifying what students have done wrong, those kinds of things. They show up on tests. I haven't written your test yet, so I don't know if they're going to show up on Thursday or Friday, still not the right day, Wednesday specifically. But there's typically things in there that ask you to think about what's right, what's wrong. And that's a very common way to ask questions too, because that's part of what we want to be able to do, is to go out in the schools and actually be able to use what you're learning. All right, we got Amy. Amy's friend told her that the ratio of boys to girls in her classroom was 5 to 6. Amy was surprised that her class would have only 11 students. What would you tell her? There's lots of things you could tell her.
You don't add the ratios.
What's that?
You don't add the ratios to get the total.
Actually, you kind of do, but not necessarily in this way. So let me make one comment first that you probably aren't thinking, and it's not really what this problem is about, but it's a true statement, is that maybe you do have 11 students, right? Maybe you're working in a private school. Maybe you're working with a special ed program, so you've got fewer numbers of students per person. I mean, like, there are situations where maybe you do have 11 students. Okay, so one option is maybe there are. Now, if you stop there in this problem, I'm not going to be particularly happy, because that's really not the point. The point is, it doesn't have to be 11. It could be, but it doesn't have to be. So let's assume now that it's not 11 and figure out what else could it be, or what could be the misconception. Because there is something going on with the 5 and the 6 to be 11, like Asia noticed. So what else could be happening here? How many other students could you have? Let's ask it that way. Yep.
Couldn't it be 10 and 6?
It could. So
Or
I
10 and
don't,
12.
10 and 12, there you go. So it could be, that's 22, by the way, 22 students. And the reason is because, like you just noticed, 5 to 6 is equal to 10 to 12. It's just that 5 to 6 is reduced and 10 to 12 is not. All right, so it could have 22 students. That's probably pretty realistic, but you could have,
Like, why am I, like 33 or
33.
33 or...
I hope you don't have 44, but maybe you do. I don't know. Maybe you're the PE teacher, and you've got the classes combined at once. That's possible, right? 55. So maybe you're teaching middle school and you've got 99. I don't know, right? ... Lots of options. What's going on? Why are these incrementing by 11?
You're just increasing the proportions.
Yeah, so we have the 5 over 6, and it is the reduced, this is the kicker here, number 4. 5 over 6, and I'm writing it as a fraction like this because it's a little bit easier to think about, I think, in terms of reducing. 5 over 6 is a reduced fraction. At least it's a simplified fraction. It's a reduced fraction. So any value 5x over 6x for x equals, and you can do 1, 2, 3, 4, right? You can multiply top and bottom by 4, top and bottom by 5, would be an equivalent fraction, or a ratio, we'll say it that way. And 5x plus 6x equaling 11x, right? Our total number of students. Probably going to be the 22 for most lower level classrooms, I would hope, given the circumstance. Any questions on that? All right.